Hello dear students, welcome back to YouTube classes on data communication subject. So today we are going to continue with module 4. The topic here is introduction to data link layer. So you have to refer chapter 9 from Horizon textbook. It is in the second part of your fourth module, whatever I am going to cover in this video and in the next video. So in this video we are going to talk about introduction to data link layer. So as you all know, TCP/IP model consists of 5 layers: physical layer, data link layer, network layer, transport layer, and application layer. This we have learnt in first module. So in all these modules till now, we have learnt first layer in detail, that is the physical layer, how data is represented there, and what are the things that we have to learn in physical layer we have studied till now. So in this chapter we are going to study about data link layer. It is just an introduction to data link layer. So it is in chapter 9. So here in this chapter you have two parts. First one is introduction to data link layer, basic concept, and second point is link layer addressing. That is the second concept you are learning. So in first concept we are going to learn about, in first section we are going to learn about the introduction to data link layer. So it starts with the definition of links and nodes, and it briefly describes what are the services provided by this data link layer, and it defines two categories of links, that is point to point and broadcast links. So these links we have already learned. Point to point means to the link which is dedicated to two hosts, and broadcast means the link that is used by many hosts that are communicating with each other. So the section finally defines two sub layers of data link layer that we will discuss, that is DLC and MAC layers are the two layers. This is all about first section, and in second section we are going to discuss about link layer addressing. So we have we know network address or IP address, something like that. So here we are discussing something called as link layer addressing, which is we will going to study how it is different from network layer addressing and what is this link layer addressing. And we have a protocol here, that is address resolution protocol, and what it does we will study. So here we can discuss it briefly. ARP, that is address resolution protocol, maps the addresses at the network layer to the addresses at the data link layer. So addresses at the network layer we can call them as logical addresses, whereas addresses at the data link layer we can call them as hardware addresses, right? So or physical addresses. So in other words, ARP, that is address resolution protocol, can be said as it converts logical addresses into physical addresses or hardware addresses. Okay, we'll move to the next part. So let us start our lesson with this diagram. So the same diagram you have seen in chapter 3 or in module 1 when we were discussing physical layer. So the same diagram I'll take, and we will take the same analogy. What analogy we did? We sitting at the Sky Research are ordering books online. The other day in class I have told you. So what are the scenarios you will face, or what are the links, routers, switches through which you will come, is shown in this diagram. This is figure 9.1. So there you have learnt about physical layer. Everywhere you have learnt about physical layer there. What are the interactions that are done in physical layer, that we have learnt in that diagram. But in today's chapter, here we are referring to data link layer everywhere. So data link layer here at Alice is a person and Bob is the another person. We can call them as source and this one as destination. So how data link layer at each point, that is this is first point, this is second point, this is third point, fourth point, fifth point, and sixth point of interaction or data interaction, how this data link layer cope up with, or what services it will give you, or what help it will give you in the communication, that we are going to know here. Okay, so it shows the same scenario we have discussed in chapter 3, But now we are interested in communication at data link layer. Communication at the data link layer is made up of 5 separate logical connections between the data link layers in the path. Finally, the data link layer at Alice computer communicates with the data link layer at the router R2. So this is that connection, that is Alice's computer communicates with the data link layer at the router R2. What is the next connection? What is the next connection? As you can see from the figure, the R2 communicates with the data link layer of R4. R4 communicates with the data link layer of R5. R7 communicates with the data link layer of Bob's network, and that's the end, where it ends there in the network. So only one data link layer is involved at the source or the destination, but 2 data link layers are involved at each router. So the reason is that Alice's and Bob's computers are connected to a single network, but each router takes input from one network and sends output to the another network. You should note that although switches are also involved in the data link layer communication, for simplicity we have not shown in this figure. Okay, this is that. So that is, we come across data link layers, that is in routers we will come across 2 data link layers, whereas Alice and Bob at the end sources we have only one data link layer to do that job. That is what we can infer from this figure. So going to the next point, we have nodes and links. So I have a figure, I'll explain with that. Observe the figure. Here, communications at the data link layer is node to node. Okay, communication at this layer, whatever layer we are talking now, is node to node. A data unit from one point in the internet needs to pass through many networks. That is, it may be a LAN or it may be a WAN to reach another point. These LANs and WANs are connected by routers in between. You can see routers here. So these are the routers. So these LANs and WANs are connected by routers, and it is customary to refer to end hosts and routers as nodes. So these I call them as nodes. So first 2 are our source and destination, and these are connected through a network. So in the network, so whatever hosts I have, I call them as nodes. Okay, whatever hosts are there, end hosts and the routers, I call them as nodes, and the network in between I call them as links. Okay, have you got to know what is a node and link? So nodes are end devices, whereas links are the networks between the end devices, are called as links. So this figure gives you a simple representation of links and nodes when the path of the data unit is only 6 nodes. So we have only 6 nodes here. So the first node is the source host, the last node is the destination host, the other 4 nodes are 4 routers. So the first, the third and the fifth link represents the 3 LANs. The second and the fourth represents the 2 WANs. Okay. Then next point is services. So what are the services this data link layer provides us? So observe the figure there. The data link layer is located between the physical and network layer. When you observe a TCP/IP model, you can come to know that the data link layer is the second layer. So the first layer is physical layer, second layer is data link layer, third layer is network layer. So the data link layer exists between physical layer and network layer. So the data link layer provides services to the network layer. It receives services from the physical layer. So let us discuss services provided by data link layer now. So the scope of the data link layer is node to node, as we have discussed in the previous slide. So when a packet is traveling in internet, the data link layer of a node is responsible for delivering a datagram to the next node in the path. So for this purpose, the data link layer of the sending node needs to encapsulate the datagram received from the network in a frame, and the data link layer of the receiving node needs to decapsulate it. So we should remember here, the receiving node has to encapsulate using data link layer, and the receiving node decapsulates, whereas sending node should encapsulate using data link layer. Okay, so this is the thing we have to get to know. Observe the figure 9.3 here. It shows the encapsulation and decapsulation at the data link layer. So what happens at source? Encapsulation happens. What happens at the destination? Decapsulation happens. So for simplicity, we have assumed that we have only one router between the source and destination, but in reality we have thousands of routers in between source and destination. So the datagram received by data link layer, so this is the datagram. Datagram is nothing but some data. You think it as some data. Okay, so datagram received by the data link layer of the source host. Here we are talking about this source. The datagram received by the source host is encapsulated in a frame. So what is frame here? Frame is collection of some datagrams or bits, in other words. Okay, so the datagram received by the data link layer of the source host is encapsulated in a frame. The frame is logically transported from source host to the router. The frame is decapsulated at the data link layer of the router. Here it is encapsulated here, it is decapsulated here, and again encapsulation happens. Again it is sent to this link of type 2, and here what happens? Again we come across decapsulation. This we have learned in first module. The same concept applies here also. So the frame is decapsulated at the data link layer of the router and again encapsulated at another frame. The new frame is logically transported from the router to the destination host. Okay, so we have to note that although we have shown only two data link layers at the router actually has three data link layers because it is connected to three physical links. Okay, then what are the important services this data link layer gives us? So it is not given in slide, please note down. So the important services that are given by data link layer are, the first one is framing. So it helps us to create frames. Okay, so the data will be in the form of frames. Here we have learned this in first module, objects in each and every layer. So the object in physical layer will be bits, the object in data link layer will be frames, the object in network layer will be packets, the object in transport layer will be messages, and so on. This we have learned. Okay, so data link layer, its service is it provides framing, that is it collects bits to make frames. Okay, then another important service it provides is flow control. So whenever we have a producer and a consumer, we need to think about flow control. If the producer produces items that cannot be consumed, here the producer is source and consumer may be network or destination. Okay, so if the producer produces items that cannot be consumed, accumulation of items occurs. So the sending data link layer at the end of a link is a producer of frames. The receiving data link layer, as I told, is the consumer. So if the rate of produced frames is higher than the rate of consumed frames, frames at the receiving end need to be buffered. Means they have to be made to wait in the queue. So definitely we cannot have an unlimited buffer size at the receiving side. So we have two choices. The first choice is to let the receiving data link layer drops the frame if the buffer is full, or otherwise we have to tell the data link layer of the sender to slow down the output of the frames. So that is called as flow control. Okay, so the first service data link layer produces is framing, and the second service that it provides is flow control, and the third service that it provides is error control. So at the sending node, a frame in the data link layer needs to be changed to bits. So whenever due to noise and other things, if the data is, or if there is some error in frames, it should be known to the receiver. So that is called as error control. Then the last one is congestion control. Congestion control is nothing but we have to look about the traffic of the network. The network should not be over trafficked. So that is called as congestion control. So data link layer provides you four services. The first one is framing, the second one is flow control, the third one is error control, and the fourth one is congestion control. Okay, these are the services provided by data link layer. This is an important question, please mark down. The next concept is to two categories of links. So there are two categories of links. The first one is, as we all know, the first one is although two nodes are physically connected by a transmission medium such as cable or air, we need to remember that data link layer controls how the medium is used. So we can have a data link layer that uses the whole capacity of medium, or we can also have a data link layer that uses only a part of the capacity of the link. So to better understand, the two types of links are point to point or a broadcast link. So here the first part, whatever we have told, that is, we can have a data link layer that uses whole capacity of the medium, can be said as point to point, P2P it is called as. Then the other one is called as broadcast. Okay, so wherein we have a data link layer that uses only a part of the capacity of the link. This is called as a broadcast link. So in a point to point link, the link is dedicated to the two devices. In a broadcast link, the link is shared between several pairs of devices. So for example, when two friends use a traditional home phones to chat, they are using a point to point link. When the same two friends use their cellular phones, they are using a broadcast link. Okay, that is the analogy that I can give. Then next concept is two sublayers for this data link layer. So I'll show you the figure. We have another part. So these are the two sub layers. To better understand the functionality of and the services provided by data link layer, we can divide the data link layer into two sub layers. The first one is data link control, that is DLC, and the second one is media access control, that is MAC. So this is not unusual, because we will see in the later chapters, upcoming chapters, LAN protocols actually use the same strategy. Okay, that is dividing. The data link control sublayers deals with all common issues to both point-to-point and broadcast links. The media access control sublayer deals only with specific issues to broadcast links. So in other words, we separate these two types of links at the data link layer. So it is shown in figure, in this figure. Okay, so we will discuss DLC and MAC sublayers in this module. We have already discussed in another video. So this is the division of data link layer into two sublayers. So the two sublayers are data link control sublayer and media access control sublayer. So we'll move to the next part, that is second section of this video, that is link layer addressing. So what is link layer addressing? So in chapter 18 we will discuss about, that is in the next part of this module, we will discuss about IP addresses or network layer addresses as the identifier at the network layer. So identifier at data link layer is link layer addresses, whereas identifiers at network layer is IP address or network address, or it is also called as logical addresses. So however, in an internetwork, please note that point, internetwork such as internet, we cannot make a datagram reach its destination using only IP address. So the source and destination IP addresses define the two ends, but cannot define which links the packet should pass through. So we need to have something called as link layer addresses for this to overcome that problem. So that's why link layer addressing came into existence. So IP addresses provide as or become as identifiers at the network layer. So however, in a connectionless internetwork such as internet, we cannot make a datagram reach its destination only by using IP addresses. So we need link layer addresses. So we need to remember that IP addresses in a datagram should not be changed. If the destination IP address in a datagram changes, the packet never reaches its destination. Okay, I'll show you with the figure. This is the figure that we are going to learn. So in this figure, we have three links. Can you observe three links here? This is first link, link 1, this is second link, link 2, and this is third link, link 3. So there are three links. We also have Alice and Bob. They are sharing their data. Two hosts, we can consider them. Alice is a source and Bob is destination. For each source, we have shown two addresses. The IP address N here represents IP address, whereas L represents link layer addresses. Okay, getting the information? Yes. So N represents network layer addresses and L represents link layer addresses. Note that our router has many pairs of addresses as the number of links the router is connected to. See, this router has this address is link layer address, this link layer addresses, and two more connections here. Those addresses it will be having. So it has many addresses, in other words. So each frame, we have shown 3 frames here. These are the 3 frames. So frame 1, frame 1 I'll mark, frame 2 and frame 3. I'll take away all the marks. Okay, I think you remember all the picture. We have shown 3 frames here, one in each link. This is one link, this is one link, and this is one link. We have 3 frames, each one in each link. Then each frame carries the same datagram with the same source and destination address. So we have N1 as source address and N8 as destination address. That is, Alice's IP address is N1 and Bob's IP address is N8. So our frame should consist of that data. That is, N1 is source IP address. Excuse me. N1 is source IP address and N8 is destination IP address. Okay, so source IP address, destination IP address, and data is one part of the frame. In another part of the frame, we have something called as link layer address. Pair of link layer addresses we have. What are those? The link layer addresses of the frame change from link to link. Observe the link layer address. So this part, whatever I have circled here, N1, N8 data, is same in all the frames. But what is changing? The only thing that is changing is link layer addresses. That is, through which link it passes is given in link layer address. So each frame carries the same datagram with the same source and destination address, but the link layer addresses change. So in link 1, the link layer addresses are L1 and L2, as you can observe there, and in link 2 they are L4 and L5. In link 3 they are L7 and L8, right? So this is it, L1, L2, L4, L5 and L7, L8. Okay, so to which link they are passing next is given as link layer address, right? Then IP addresses, for IP addresses the source address comes before the destination addresses. For link layer addresses, the destination address comes before the source address, right? So while writing IP addresses, we have to write first source address, then destination address. But for the link layer addresses, first you should write destination address and then source address. That's it. That is the only difference between network layer addressing and this link layer addressing. So in the next part of this section, we are going to learn about 3 types of addresses. So what are those 3 types of addresses? Three types of addresses are unicast, multicast, and broadcast addresses. So what is unicast addressing? So each host or interface of a router is assigned a unicast address. Unicasting means one-to-one communication, whereas multicasting means one-to-many communication. And what is broadcasting? Broadcasting is one-to-all. Okay, there is difference between multicast and broadcast. Can you get to know what is the difference between multicast and broadcast? I have already explained in this class, this point in the class. So multicasting and broadcasting. Get to know, Google it, and answer this query in comment section. I'll see how many of you will answer. Okay, so unicasting means one-to-one communication. So that is, unicasting is one-to-one communication. A frame which is a frame with a unicast address destination is destined only for one entity in the link. So as we can see in this figure, the unicast link layer address is the most common LAN. LAN Ethernet. It consists of 48 bits, 6 bytes, that is represented as 12 hexadecimal digits separated by colons. So you can observe here, this is 12 hexadecimal digit separated by a colon. The following is a link layer address of a computer. So you can see here, this is link layer of address of a computer. So the second digit needs to be an odd number here in unicast link layer addresses. Okay, going to the next type of addresses, that is multicast link layer addresses. So multicast link layer addresses, some link layer protocols define multicast addresses. So multicasting means one to many communication. So however, the jurisdiction is local, that is inside a link here. So it is again represented as 12 hexadecimal digits separated by colons, but the second digit, however, needs to be an even number in hexadecimal. See here, this second digit should be this thing, even number. Okay, going to the third kind of addresses, that is broadcast address. So since link layer protocols define a broadcast address, broadcasting means one-to-all communication. A frame with the destination broadcast address is sent to all entities in the link. So here the broadcast link layer address is also again a 48 bits, all ones that are presented as 12 hexadecimal digits, which are separated by colons again. So the following shows the broadcast address. This one, FFF, all Fs. So this represents broadcast address. Okay, then the next and the last part of this video, that is address resolution protocol. So what is address resolution protocol? So anytime a node has an IP datagram to send to another node in a link, so it should be having IP address of the receiving node. It is must and compulsory. So we will discuss this with an example. This is where ARP stands. It is one of the protocol in network layer. As I have told you, whenever an IP datagram should be sent to another node, it should have IP address of the receiving node. The source host knows the IP address of the default router. Each router except the last one in the path gets the IP address of the next router by using its forwarding table. There will be one forwarding table which is used to get to know which is the next router to be followed by a packet or IP datagram. So the last router knows the IP address of the destination host. So however, the IP address of the next node is not helpful in moving a frame through a link. So we need the link layer address of the next node. So this is the time when ARP comes into picture. So the ARP protocol is one of the auxiliary protocols defined in network layer. So you can see there are 4 protocols in network layer. That the first one is ICMP, IGMP. ICMP is for control messages, IGMP is for group messages, IP is connectionless protocol, and ARP is address resolution protocol, so which converts logical addresses into hardware addresses. So the ARP protocol is one of the auxiliary protocols, as I mentioned. Then it belongs to the network layer. Okay, this is a gate question. So ARP belongs to network layer. Then ARP accepts an IP address from an IP protocol. It maps the address to the corresponding link addresses and passes it to the data link layer. We have its contrary part, that is RARP, that is reverse address resolution protocol, which does exactly the opposite task of ARP. So anytime a host or a router needs to find the link layer address of another host or router in its network, it sends an ARP request packet. So we have figures. ARP, this is ARP operation. One more important question. So ARP request in broadcast, ARP reply is unicast. So please keep this thing in mind. This is an important question. Please write it down. So explain ARP operation with neat diagram. So always ARP request is broadcast. So it requests to everyone, whereas it gets reply from one of the nodes. Okay, so anytime a host or router needs to find the link layer address of another host or router in its network, it sends an ARP request packet. So this packet includes the link layer and IP address of the sender and the IP address of the receiver. Because the sender does not know the link layer of the receiver, the query is broadcast, right? I told you the query will always be, or the request will always be broadcast over the link using link layer broadcast address. So what is the link layer broadcast address? FFF, all Fs, 12 hexadecimal numbers. So once this is discussed in the last slide. So every host or router on the network receives and processes the ARP request packet, but only the intended recipients recognize its IP address and sends back an ARP response packet. So here this is giving reply, system B is giving reply, I am the node and my link layer address is L2. So this is giving reply to system A. So whereas system A in the first slot, it is looking for link layer address of a node with IP address N2. So this sends request to all the nodes, to this node, to this node, to this node, whereas each of them will check whether the IP address of this system is N2. No, this is N4, so it discards. So the coming to the next one, whether the IP address of this node is N3. No, it is is it N2? No, it is N3. So this is also discarded. So this also discards this request. Whereas coming to system B, what system B recognizes? System B recognizes that its IP address is N2 and the request is made for this system only. So it sends the reply back. It sends the reply back that its link layer address is L2. Okay. Now what I got? I got link layer address from network address, right? So this is how the operation of ARP happens. So in this figure, the system on the left, that is A, has a packet that needs to be delivered to another system with IP address N2. So system A needs to pass the packets to its data link layer for the actual delivery, but it does not know the physical address of the recipient. So it uses the services of ARP. So by asking the ARP protocol to send a broadcast ARP request packet to ask for the physical address of a system with an IP address of N2. So this packet is received by every system on the physical network, but only system B will answer. So this is what is the operation of ARP. Okay, then this is ARP packet. It is 32-bit long. Okay, this is ARP packet. It is 32-bit long. The names of the fields are self-explanatory. The hardware type, this one, it defines the type of the link layer protocol. Then Ethernet is given the type 1. Ethernet is given the type 1. Then the protocol type field defines the network layer protocol. IPv4 protocol is, it has some fixed value. IPv4 protocol has some fixed value, that is 0800 to the base 16. The source hardware and the source protocol addresses are variable length fields defining the link layer and network layer addresses of the sender. The destination hardware address and the destination protocol address fields define the receiver link layer and network layer addresses. An ARP packet is encapsulated directly into a data link layer frame. So the frame needs to have a field to show that payload belongs to ARP and not to the network layer datagram. Okay, so this is ARP packet. Again, this is also an important question, VTU question. So that is explain ARP packet and ARP operation. These two questions from the two slides can be clubbed and can be asked for 8 to 10 marks. Okay, each carrying 5 or 4 marks. Okay. So an example is there. Example 9.4. So I'll read it out. A host with IP address N1 and MAC address L1 has a packet to send to another host with IP address N2 and physical address L2. The two hosts are on the same network. Figure 9.9 shows the ARP request and response messages. So this is figure 9.4. Sorry, 9.9. Example 9.4. So what we have to do here, to show communication is done at the data link layer and how link layer addresses are found, let us go through a simple example. This example, study this example. What is happening here? We will go thoroughly into it. Nothing more difficult here. System A is source and system B is destination. Okay, system A has IP address N1, system B has IP address N2. System A has a link layer address L1, system B has link layer address L2, but it is not known to A. That is the problem that we have to know. Okay, then according to the operation of ARP that we have discussed a few slides before, what happens here? To show how communication is done at the link layer, data link layer, and how link layer addresses are found, so we have to solve this problem. Assume allies need to send a datagram to Bob, who is 3 nodes away in the internet. This is it. How Alice finds the network address of Bob is what we have to discover here. For the moment, assume that Alice knows the network layer address of Bob. In other words, Alice host is given the data to be sent, the IP address of Bob, and the IP address of Alice host is known to him. Then figure 9.10, this figure shows the part of the internet for our example. So what are the activities at the Alice site? So these are the activities at the Alice site. We will use symbolic addresses to make the figures more readable here. So this is what happens at the Alice site. So what happens at the Alice site? So this is the thing. Here what happens is it will send a datagram which has payload and which has address of source and address of destination. This we have known, and this frame should also need to be have L1 and L2 attached to it. What is L1 and L2? It is destination and source address of link layer addresses. Actually it is link layer addresses. So L1 is the next host address, that is it goes to link layer 1 and it has came from LA, that is source link layer address. So like this we will build a forwarding table, something called as forwarding table, which has link layer addresses. So if something comes from this point, this is the next point. If something comes from allies, it has to go through this point. Like that we will build a forwarding table which will help here for ARP, right? So these are the activities at ally side. So these are the activities at router. These are the activities at router R1. Now what happens here? Again here first we will decapsulate in this manner, and again we will encapsulate in this manner. So we will come to know to which link it should be forwarded to, and from which link it has came, and that information is decoded between this decapsulation and encapsulation. So these are the activities at router R1. So coming to the activities at router R2. So these are the activities at router R2. Again router R2, it again decapsulates and encapsulates back by putting correct addresses, link layer addresses, using the forwarding table. So at Bob's side, what happens? If Bob is the correct receiver, it get to know that I am the correct receiver, and it will send the link layer address to the this one allies using this ARP protocol. So this is how operation of ARP happens. Okay, so this is all about data link layer, introduction to data link layer. So it is in chapter 9. We have 2 sections here, 9.1 and 9.2. Please go through this video thoroughly, and if you have any doubts, please ask me in the comment section. Okay, so in the next video we'll see about network layer, especially about IPv4 addresses. I'll continue in the next video about that. Okay, till then, take care. Bye.